You all know me as a meetup organizer, but I actually also do web performance work. I worked at the Meetup a few years back, the company, right? And most recently I worked at Etsy. I run web performance teams, kind of concentrate on culture of performance, technical aspects of performance, architecture, things like that. And I kind of want to apologize in advance because this presentation is relatively rough. And kind of like very early presentation because the topic is very early, very kind of not discussed very much, right? And you will see a few slides that you will recognize the problem very quickly. And it was born from the feeling that I got that the rigidity of our architectures today causes us to have slower websites. It causes a lot of other things and generally innovation, but performance is in particular, right? And I concentrate on web performance, so a lot of my examples will be web specific, right? But I assume this applies to everything, right? And you will see what I'm going at shortly. So there will be more questions in this presentation than answers, but I hope this will help us all deal with this problem because the right questions sometimes might be useful. Again, no promises of usefulness. Just listen to me. You tell me if it was okay or not. Before we go into flexible architectures, I want to tell you a story though about the little rover that is out there on Mars, right? And I'm sorry it's not to scale and they didn't have a chance to paint it properly. But the rover likes exploring, right? It's exploring the Mars, it's roaming, scanning surrounding areas, and takes a photo of the plant. And it needs to figure out, what is this plant? Do I know this plant? Do I not know the plant? So the question comes, and we all know that the rover actually is a nuclear device. It has like nuclear power plant inside of it, like a tiny one, so it has a lot of energy, somewhat, right? But it is there forever, so for a long time, right? So, resources are limited, right? The compute resources are limited because it landed there a while ago, and you cannot put a lot of computation there. And energy is limited, connectivity is limited, things like that, right? So should it compute it on its own embedded computer, or should it send it to the Mars base maybe, right? Which is not too far, but has Mars file latency and has better computers though, right? But latency is kind of a problem. If you need the immediate decision, it might be a little too slow to, and whoever knows about the storms on Mars, like it might have packet loss and stuff like that, right? And obviously the base doesn't exist yet, so that's kind of a problem, right? But we can plan for things in the future, right? Satellites, however, they are there. They were first there, right, before the rover was there, right? So maybe it can communicate with a satellite. And the problem, obviously, is more latency. What if satellite is on the other side of the planet right now, right? It actually can't, just so you know. It can't communicate with a satellite that it cannot see. I don't know the old physics, but if it can only communicate with it from time to time. So the packet loss is variable quite a bit, right? But it has like solar panels, right? So it has energy, quite a bit of energy options. Probably can have more computers on it because you don't need to land them on the ground. So probably more of them survived the landing. Well, no landing, I guess, the travel. So where should the computation be, right? That's a question. The next question is, why do it on Mars? Maybe we should do it on Earth. We have a lot of computation on Earth, right? We have other satellites around Mars and probably in vacuum, they can communicate pretty well without going through atmosphere. Same kind of problems like with Mars satellites, but we have more of them, right? Or should that be mission control center, right? The heart of computation in NASA, right? or maybe our ISS station, or maybe moon base, again, soon, coming soon. Or maybe it can be cloud, right? It's funny to have a word cloud in this context, but we know what I mean by the word cloud now, right? So anyway, this kind of a question, when you phrase this question in this huge scale, it kind of becomes obvious that these choices need to be made, right? Like, you cannot just send like a thing to Mars and not make those choices, right? In fact, you might want to change those choices the moment you have the base, or well, you land the rover, not just have a satellite. In fact, interestingly enough, Vint Cerf, co-creator of TCP/IP, actually worked on some of it, and worked on interplanetary internet. If you're not familiar, check it out. I don't remember exact year, probably 2008, 2014. Some of those years come to my brain, but like, check it out. There is an article on Wikipedia where they solved some of those communication problems, basically protocol problems of buffering, latencies of 24 hours, and like, or stuff like that, right? Which is a first stepping stone in solving some of these issues, right? I'd like to thank Alex for helping me style this slide. It's like, looks very, very spacey, right? But let's get closer to Earth, right? Let's talk about Jane, who has a phone, and she likes exploring, and she likes taking photos of plants, and she needs to figure out, did she see this plant before or not? Kind of rings a bell, right? And that's because, like, most of the time it's also like has some server somewhere out there, right? Like, all of these applications have the server. And we are talking about web tonight, so like, I will probably mostly talk about web technologies, but like, some of the phone internals have many different places to run the code, right? Like, we got used to basic HTML to JavaScript on the main thread, but there are web workers now, there are service workers and progressive web apps to do some computation, right? Before it talks to the server, right? But there's also cloud, same cloud, from different sides, right? We all know by now that the servers don't have to be like those boxes, like the one sitting right there, thanks to companies like Fastly, but cloud is something that we all got used to, right? Some computation out there that we don't need to worry about it too much, except for latency and availability requirement and all of that, right? But there is also edge, right? And that's what CDNs are, right? Like, CDN caches were there even before cloud existed, right? Like, basically you can cache the resources before between communication from server to the client, and you can keep the resource for a while there, right? And next time user comes, you can just reuse the same resource, right? That became a great empowering technology, like, allowed a lot of scalability, performance wins, and so on. And now there is serverless computation, right? Where the cloud doesn't only have like big servers like we had those big boxes before, we just rented them in cloud. Now there are like things that you don't even know that there is a server, right? Like, it's just there. It's like just little piece of code that you can deploy, and you don't need to worry about even more, unless you do, right? There are also various services, not just code that you run, but there are some services that you're like, oh, we'll just do it for you, right? Like, we have our own computational, particular specific computational thing. If you listed Amazon services recently, I don't think like I've ever scrolled down to the bottom of it, right? But this is another like a thing that's available to you, right? Do you pick that, or do you build your own? That's also a thing. And now there is edge compute as well, right? So the computational power is no longer only in the cloud, but it is also available on the edge as well, to certain degrees, certain loads and stuff like that, specializing. So specializing in particular things, right? So they all are interconnected, or at least they should be interconnected, and you should be using as many of them as appropriate for your application, right? Yeah, why did I do the space example or the phone example? Because, for different pieces of this application, the decision will be different, right? If it is just making a photo, probably local, right? You probably keep it local for now, right? If you need to do AI recognition or whatever the magical thing they promote these days, that's probably going to be happening on the server or on the client if the recognition needs to happen just a little bit. If you need a lot of data, do you keep it locally and cache, right? Like, did you copy all the database of all plants prior found on Mars onto rover? Today, you probably can't, because I actually am not aware of any plants found on Mars, right? So that's pretty easy, right? But as they come about, like, it will be relatively small data set there, right? But if you want the whole Wikipedia, okay, Wikipedia, maybe not that big. But if you want the whole internet or however big data sets, probably not, right? So all of those decisions need to be made appropriately to the product you're building. In fact, they need to be made appropriate to the portion of the product, right? Because your product, your application should contain multiple features, or at least usually contains multiple features, and architectures for different features should be picked appropriate for the use case. And I feel that we got into the habit, or maybe it's normal for now. I don't know if it's a habit. Maybe it's a like normal state where we pick the architecture first, then we do development. It's very hard to re-architect things. And I propose that for us to be able to innovate, to make faster applications, we need something that I call flexible architectures. It's not an invention or anything. It's just a concept that we should be flexible about the architectures that we make. How many of you did re-architecture before? Raise your hand. Okay, a few. How hard was it? How successful were they?
Very successful.
Okay, nice. How many of you feel that we should be rebuilding the application, like architecturally, the one that you work on now? Okay, quite a few of you. And the rest of you are just like shy about it. It's fine. But
Fine should, I think.
should is very should. Yeah, I agree. Because they're usually business case, right? But to accomplish the optimal experience for the users, imagine you okay. Many of us in our life had a thought: what if we didn't have existing application and could just build from scratch? Right? That is kind of the feeling that I have, right? And I don't mean it's a good feeling, right? Like oftentimes when this feeling visits you and you bring it up to organization, it's a bad feeling because frankly, you either need to fight very hard for it or you will be like kicked quite a bit, right? Neither of those are successful, as it turns out, right? Many examples show that if you're trying to rebuild everything from scratch, usually you fail even harder than what you had, right? Primarily because nobody remembers all the details that were built into the system, right? So, as I said, having many architectures within one system is very hard. Usually we pick a few, like search is a good example, good exception to the rule, right? Search architecture is very different from regular web application architecture, right? Like the indexing happens very differently. You don't search through, Google doesn't search the whole internet when you enter the query. That's a Google, right? Neither do you on your website. You don't just run your all computation on all your data, unless data is small, right? Which is appropriate. But generally speaking, we don't have that many architectures. We think of them very hard when we build the product first, and we don't change them. And I've been through a lot of these conversations, and hence the talk, hence like me spending so much time on it. And I wanted to make performance impact. And oftentimes, when you talk about caches, by the way, cache is a great solution. Everyone forgets about cache invalidation, but cache is a great solution. And every time this is brought up, and I'm only bringing it up because it's a simpler example of it, right? Every time it's brought up, I see a lot of pushback because everybody says, well, but everything is dynamic, right? Like we cannot cache anything, everything is dynamic. I know Bud here, like organizer of static generation meetup, aka Jamstack, right? And formerly known as the new dynamic, can attest to that, right? Like static generation fit one use, well, a few use cases very well, but it's almost impossible to bring to universally, even though every website has static components to it, right? Anyway. So this excuse of everything is dynamic is basically your signal that, you know, it will be a hard work to convince people. And in general, this is not for bad reason. Like you said, define should, right? Technology is hard. Introducing new technology is hard. Like I don't want to say, oh, they all bullshit, right? Like they all just keeping their seat warm, right? Like whatever, right? No, it's hard. It took us about a decade before single-page applications became an architecture, right? From introduction of Ajax or whatever we were calling it, right? Before it became called single-page applications to begin with, right? As I said, static generators often perceived are not dynamic, and therefore, like yeah, we cannot use that technology. Again, you probably should for things that are static, right? And PWAs, edge compute, there are a few new technologies. Like they're very new, very kind of complex and stuff. How many of you are comfortable with progressive web apps and edge computation? I have one person, 2, 3, awesome, awesome. I mean, we wouldn't be at the web performance meetup if it wasn't the case, right? But if you ask general developer populations, they're very hard, right? So I want to, oh yeah. Before we go into talking about a few of those architectures into a little bit more detail, I want to say that I spend quite a bit of time trying to put content on this slide, right? Basically, the fact that without re-architecting these applications, it's almost impossible to make things faster, right? And I actually couldn't think of good statistic that I can put here or good supporting material to put here, right? But my gut feel tells me that it's true. My experience tells me that it's true. So maybe we should think together about like, what can we put here? Like, what is there? Like, why is that the problem? I can assume many of you were stuck in the old architecture and couldn't move into like progressive web apps, for example, right? Like, how many of failed projects like that have you seen, right? So anyway, I just want to say that more questions than answers in this presentation, so hopefully you forgive me for not giving you the answers. So let's quickly talk about web-specific architectures, and I'll kind of try to talk about why they exist, right? Like what brought them in, what could be beneficial of using this architecture or something like that. I am saying that it's web-specific, but the whole concept here is not necessarily web-specific. We talked about Mars rovers, right? But IoT devices, quite a lot of systems that have very clear architectural constraints in one place, and network latency in between and stuff like that, where these kind of decisions need to happen. So again, think more generically about it, right? Well, let's start with our favorite. Now we call them multi-page applications. In the past, we just called them web pages, right? And yeah, there are static web pages first, but then basically a server doing some work, producing HTML, sending it to the client based on request, doing it every time. That's like what I call web pages, right? All of those technologies, very traditional. Why would we use it today? Obvious. It's normal. Everybody knows it. Like every browser supports it. Every server does it. Maybe newer developers actually don't know it anymore, but which is not that easy problem to solve. But new languages support it. Like every new language has a web server as a command line right in the first page of documentation, right? So this is something that enabled a lot of us to basically, it enabled a lot of business to go on the web, right? Like, because the moment you have computation in response to the user, everything happens, right? Like, it's straightforward. Some of us kind of like miss this simplicity of this, so that and static HTML as well, where like a lot of it was on a server in our control, right? So if you want control over software that you run, don't send everything to the client. Like, have very little to the client, only the display logic, right? And have the application logic on the server. I don't know if you liked the image here. I just like that. So like especially this arrow going into our next slide, which is single page applications. So effectively, when they emerged, like developers asked themselves, like, well, why should we always run on a server? Why can't we have logic and like a lot of our application run in a browser? Because by the time the browsers allowed that, right? And this question of where should we run the code, like how I started this talk, right? Like, this is one of the first of those questions, right? It started as client-side rendering, as many of you know. Basically, JavaScript engineers said, well, we know JavaScript. Let's write everything in JavaScript. Just ship your JavaScript, and it will run on the user's device. Which just, like, you are members of this meetup group, don't do that, right? Like, just don't do that, right? Like, I mean, don't make that blind decision, I should say, as part of this talk. Make the educated decision. Most likely, you don't want that. Sometimes you do, but most likely you don't want that. So server-side rendering was emerged, right? Like as a way of like rendering same JavaScript code on the server. Kind of universal JavaScript became a thing. You know, well, I think universal JavaScript as a concept came earlier. Like anyway, like they don't always like show up one after another. Sometimes they develop somewhat in parallel and feed each other. But hydration is another, right, concept where like you run the code on a server, send it over, then you run the code on the client and do the same thing and rehydrate. Awesome term, by the way. I like the hydration, but obviously a lot of work, and we are actually paying the price today, right? Like if you are in performance space, if you are familiar with interaction to next paint INP metric, this is the price we are paying today. It is the work that cut out for us. And it's interesting how static generators asked a different question. They also ask not where to run, but when to run, right? Why are we running the code when user came to us with a request? Why is that when we do computation? Yeah, sure, we can, and that's the most universal, like, right? They ask us something, we give them the answer. But don't we know the answer in advance? And I feel like this is basically like asking those simple questions helps a lot, right? In this space, like the answer is effectively, well, let's do it when we change the code, when we change the data, and let the user come and have it ready for them. Why not, right? I mean, there are libraries, like paper libraries out there that like exist, like books. Like you open the book, you read it, it's there. Right? Yeah, but.
Well, now we have a thing called island architecture, where most everything is pre-rendered, and then you can create these islands of interactivity, where you're putting that off into the client. One domain.
Yeah, and for the camera, Bud is mentioning that we now have combined architecture called island architecture, or at least some of them call it island architecture, where some of it is statically generated and some of it is dynamically fulfilled later, either on the server or on the client, depending on architecture we're talking about, right? And yes, this is exactly what this talk is about. Let's not just use one architecture. Let's combine the things together, right? Like do static when it's appropriate, do dynamic when it's appropriate, things like that. So asking this question of when is very critical as well. I mean, if we're talking about the space, right? Like you probably want to think about it before you send the rover over, right? And put some data on it and stuff like that. Now we have, as we talked about cloud and services, we have these little pieces of code that are lightweight, right? Like usually they are independent from each other. They run in the environments we have little control over, but we are promised some SLAs and we believe them. We are promised some performance characteristics. We don't usually believe them, but you know, and this became basically the same thing as cloud computing did to data centers. This did it to server architectures, right? Effectively, you don't care. You write code in your language, you deploy it, right? And this basically removed complexity from the code. This was very useful. That's why there are a lot of fans of it. I would suggest looking transparently in whatever they're accomplishing the non-functional characteristics for what you want. And obviously there are its own challenges with data access. Like, I mean, all of these architectures have pros and cons, right? So you need to pay attention to those to begin with, right? Anyway, I just wanted to say that these are like still very much emerging still. Like they kind of like the mainstream, but how many people work on mainstream stuff, right? Like not many. And this one is the really emerging, right? Like this is the edge compute, right? Like Fastly is a company that was one of the pioneers in the space with WebAssembly, like companies like Cloudflare. Basically, every CDN now allows you to write code that is not just configuration for your CDN node, which is the edge node close to the user, but actually code, right? They have similar problems like the services, right? Like your access to data, like your data is no longer, they all not in the same place anymore. The data access now has latency, like making it consistent. Like that's a problem for generic application. But for some use cases, this is the best place. If any of you did the A/B test enrollment logic, having to go to the server every freaking time, read out of your database just to enroll person into a bucket, it basically breaks all performance improvements, all the caching on the edge, everything. Do it on the edge, and you have yourself the benefit of the both worlds, right? And maybe if I'm talking about like some technology you never worked with, like don't worry about it. It's like it's just a very hot use case on my mind because it's kind of a problem. Some companies, I'm not going to name the names, have hard time moving away from server. Like every request has to hit server because of A/B testing in particular, right? So be able to move your compute to the edge where appropriate, right? And I'm not saying you need to replace your main database transactional logic in the edge, right? But some of this can be moved away. Again, these CDNs have it, but they're like, I think we are seeing emergence of this and and kind of like fight for where the money are and stuff like that. So it will be in flux for a while, but I think it's good. Yeah, the edge. I did Google for all those images. I didn't ask AI. Maybe somebody else did, but I didn't. And something that many of us have heard for a while now, but still have hard time using, is service workers and progressive web apps. They are much more understood now. It's effectively a CDN kind of node, but inside the user's browser, right? Like reverse proxy kind of thing, where you can have your logic on the network level, right? Like intersecting every request, and kind of like your logic can run in that worker called service worker. And there are a few other features to it, right? Like I don't want to only talk about service workers, but PWAs are kind of a thing. And I don't know if many people rolled their own. Many of them used frameworks, right? Anyone here rolled their own service worker? Okay. Okay, nice. Nice. Big company or small? Yeah. Yeah. Yeah.
Small startup.
Yeah, okay, okay. So it's possible. Again, at Web Performance Meetup, I'm not surprised, right? But generally speaking, this technology has that barrier to enter our market, and I feel like it is kind of a problem, but the amazing features that you can accomplish with it, and I'm not talking about like marketing style features or like user engagement features, I'm talking about performance features. By the way, marketing features are still useful, don't get me wrong. I'm just talking about like the things that block performance innovation, right? Offline access, we were talking with somebody just now, like offline access is a thing that this allows you to do, right? Yeah. Web workers, did anyone use web workers? Which are not service workers, no? Okay. There are a few use cases that I know of that are common, which is like WebAssembly, like heavy WebAssembly calculation that needs to happen, but you cannot go and to your server, right? You have to be online. For example, the tool that we all use at our meetup, it's called Squoosh, which is image recompression. Google released an amazing tool, online website. You go there, your image is not sent anywhere. It is recompressed in the web worker on your own device, right? But the code is written in C++ and Rust and whatever else, right? They actually ported all of those compression libraries that are usually written in C, right? And run them inside your browser, right? By the way, WebAssembly doesn't have to run in a worker, but you better do, because otherwise it occupies your main thread and your users will have choppy experience, which is you shouldn't have, right? But web workers is a technology, one of the first actually that emerged like that. It wasn't called web workers. I actually couldn't remember the name of that thing that Google had, this separate application you had to run next to your browser. Does anyone remember? No? The precursor to the workers. I think they were called something workers, but anyway, maybe I need to talk to Google folks about it, but like I was trying to get to it and I couldn't find anything about it. It's kind of hilarious. But this was a thing before browser had any WebAssembly or any other threads for that matter. Actually, they only had main thread at the time, and it allowed it, you know. So interesting, right? Like we have a technology that many of us don't use, right? Even though we know that running our JavaScript code on main thread is not always great, right? I mean, it works for event-driven augmentation of our UI, but having large loads or just even a little bit of heavy load will be detrimental to user experience. And again, maybe not many of us know about it. If you don't, come to this meetup. Every month we'll talk about it. And there are many technologies that will come, right? Like Astro, new one, right? Like there are, like that Bud mentioned, there are, like new one comes out every day, right? And as you start building your application today, expect a new technology to come out that will not be easy to integrate into your application without re-architecting of your application, right? Hopefully your application links long enough, and if it does, you will hit this problem in the future. I thought that, well, everything is invented already, like nothing new will come. I thought it every 5 years, and it wasn't true, right? I stopped thinking that way. Something new will always come out, right? I mean, I'm not talking about AR or AI or whatever, but even in the things that immediately applicable to what you make, without changing the whole industry. So, I came to think about this idea, and as I usually do, I thought, like, why do we have the notion that we have? Why should we pick architecture before we build the application? I mean, we always do, and yes, there are probably benefits to it, like we can put all of our experienced minds together and like choose the magical solution and then roll with it, right? Definitely saves us a lot of thinking down the line, right? But why do we do that? Why do we need to do that? Why can't we write logic of our application first and then choose the code, right? Choose the architecture, sorry, right? Why do we know that there is an API and the server and the client and stuff like that? Like we know that we build user experience. Okay, let's build user experience. Let's build data access. Let's build all of that without choosing the architecture. And this is the crazy idea I wanted to present a little bit about today. And I have a very short demo, not much of a demo, but hopefully you will enjoy it. Yeah, and you can tell me it's all bullshit because I think it's too crazy of an idea, so maybe you will appreciate it, maybe not, we'll see. So at least bear with me as I demo it. So the idea is that you will write a code, and this is very boilerplate-ish code with amazing names in it, and if you cannot see it, let me bump up the font a tiny bit, right? So it's a code that runs a few functions, one after another, asks for input, and we can talk about more grandiose code eventually, but this is the basics of it, right? And the application would contain code of this sort, or at least all of the code it has will be kind of, could be broken down into simpler things like that. And separately, it will have some kind of topology descriptor. And I'm writing it in JavaScript right now, but I'm not saying this is the solution, right? Like in fact, introducing all of the different technologies together, like WebAssembly we discussed, it's probably a much bigger solution. But because of that universal JavaScript idea that you can run JavaScript in quite a few places these days, that Java couldn't deliver as well, but JavaScript actually did, right? Effectively, you have this, I call it topology configuration, like topology.js, that describes basically which environments do we run this code in today, right? You can change this file, recompile your code, well, and you will have different topology of your application, different architecture, right? And you don't need to like look into details of it. The idea is that it will have some kind of name, it will have some kind of type, right? Like it will be, like in this particular case, it's HTML, right? Application, HTML environment, right? Basically, give HTML to the browser, you're done, right? Or main thread JavaScript, or Node server, right? And obviously, we'll have, you all know all the variations that could be, right? But basically, it's places where the code could run. And it will have some kind of relationships, right? Like, so this particular one says that my Node backend, which is this one over here, is my upstream, right? Like, if I don't execute here, let's execute on my upstream and get the result back from there and use the result. And also in here, this configuration specifically says, well, these two functions you execute locally, but for the rest of it, go to upstream, right? Again, this is a very rudimentary description. Don't think this is like, oh, like he made a mistake, you should do it differently. Absolutely, I made it. Like there are many, many ways of doing it differently. This is a very early proof of concept, right? So as a result, you will run a script like compiler. I'm not gonna like go into the details, and frankly, it's a mock-up more than the actual working code. And that mock-up will generate two types of code. One for the client, for each environment. One code for each environment, right? And they will look almost identical, right? With a couple variations. They will do some kind of registration of this code endpoint, right? It will instrument the code. It will make those functions asynchronous because, frankly, if you don't know if it's local or remote, you better be asynchronous, right? Like we JavaScript developers have a lot of comfort with that by now, right? Like, and a lot of Node development it's comfortable for us. Not so much for a lot of old school developers, C++ asynchronous people. Anyone? No. I mean, they make it happen for us, right? Like, but for us JavaScript engineers, but like it's hard, right? It's possible, by the way. Just I don't want to say, but like it's not the thing that you kind of do on a daily basis, you know. But so this compiler or transpiler would introduce some of those things into your code. And maybe I'm wrong. Maybe it's not going to be JavaScript. Maybe it will be a language that has those features natively, right? Like I'm not here to invent a new language, right? Like I'm too shy for that. You know, yeah. And there will be a couple things that are different for how environment delivers things, right? Like if it's HTML, you kind of work. If it's a browser main thread, you inject things into the DOM, for example, for display. And if it's a server, well, server cannot inject it into the DOM. And there will be some things that maybe limit like what you can do, right? Like you cannot access remote database from the browser directly, right? Server might, client might not. Well, sorry. I use the old outdated terms, server and client. Like one environment can, another one can't, right? Already outdated. You see, this technology works. Yeah. So yeah, and the server code will look almost identical, right? Like it's nothing special, right? Like it's a code that does logic, communicates to each other, but uses this kind of wrappers. Again, this technology now uses the wrappers, but it's just natural part of the compiler or runtime machine, right? Like I just didn't want to build a very new environment for it. And the good news is that this will also measure speed of each of those executions and will be able to tell you if you're accomplishing your requirements, right? Which, yeah, I'm not going to go too much into it, or we'll spend hours here. Okay, and it also would produce, is this? Yeah, the environment execution kind of code that basically says, well, remember that topology that described the whole topology. This will be the topology that this particular node knows about, basically what's local and what's upstream, right? And maybe there are many other variations, but like I just simplified it to this, right? So this particular one, remember, like these two functions were supposed to be called locally, right? And it returns local as an answer, and the rest of them will be sent back to the origin, right? So let me see if my demo will work, because this fake demo works. Let me see real quick. There you go. So if, I don't know, can you see that from the back? And again, our application returns amazing string of very useless characters. But the point here was that it's combined out of multiple calls, right? That's kind of the point. And if you reload this page, you will see that some of it came out of the first request, but the request for the Borg call, which was not, remember, like, sorry, I should have probably had better names for them, but that are easier to remember. But the blah and grog calls are done locally, but the Borg call is the one that's made remotely, right? And that call was sent to the server, to our, node environment. Again, server is complicated now. And it returned the result, right? So that number 5 came out of that remote payload, right? And if we go back to our logic here and we say, well, let's not do any remote. Let's always return local, right? And now if we reload this, there is no server call, same output, right? I mean, I don't think I need to describe it in a lot of detail. The concept is relatively straightforward, right? And if we go all remote instead and reload, you will see that the very first call for blah was sent to the server, right? And backend replied and output this, right? Again, this is a payload. The response was the whole thing. Sorry, I was showing you the request and not response before, right? Anyhow, it's not much of a demo yet, and maybe it never will if you all tell me this is all bullshit. But the concept is that our code did not change. Our compiler at the compile time made a choice of what is the topology of our application. Again, the word compiler is an old school word that probably means something more constrained. So maybe it's transpiler, compiler, like basically the configurator, whatever. Who knows what it is? So if you're interested, check out the Borderless framework repo. It's not much there, I can tell you. I am working on the next phase, which is a little more robust, but you know, one day. So, but my main message to you: you don't need a framework to accomplish everything we discussed, and you probably will not accomplish everything we discussed on day one. You probably cannot easily incorporate all of this technology in a flexible way. But think of this as a methodology framework and not code framework, you know. So what can we do today without any frameworks, right? Like, don't wait for me to code this. Definitely, you will wait for a while, unless you join me and we'll all make it together. But even then, like, it will probably not apply to every use case in a foreseeable future, while I'm alive at least. You know, progressive enhancement, and again, a lot of it is web specific, right? Think of which components need to do what and when, right? And that's what the basic description of progressive enhancement is. Break down your apps into smaller parts and layers that are easier to re-architect, right? That are easier to compose your ultimate set of architectures into, right? And make those choices appropriately, right? Don't just say, oh, we always did the server thing, or we are JavaScript people, or we are Node people, or we are PHP people. Don't make that a choice. Don't make that force your choice, right? It's hard. It's hard, very hard to. The hardest thing is to combat this ingrained notion of we always did that, or like people smarter than me did that, so they were right, right? What is it called? The bias, authority bias, right? Something of that sort. Like the worst thing that happens to our universities, right? Like our professors are responsible for us not succeeding, right? But at the same time, they teach us to succeed, right? Like I'm not blaming them; it's just normal, right? I don't know if that's the answer about declarative things, right? Like, I feel it might be the answer where it's appropriate. Make sure you can flex things around instead of hard coding the code. But I'm not that much of a computer scientist to tell you like that's a better approach, right? There are a few web developments recently that you should probably, well, some of them not so recently, that are kind of towards this. Some of them are very old, like. Does anyone even remember the word universal JavaScript? I know I used that a few times, right? It was how we called that thing, that you can run it on server and on client, and it will produce the same menu. And suddenly the server output could be converted to JavaScript, like client-side application, like before SPAs were a thing. Right? Basically, the fact that we can run it everywhere, same code everywhere. Event-driven data, which is somewhat of a new for web applications, right? Like we did that in the data world for quite a while. So stop thinking of your SQL is the only way of requesting your data or move your data. Like you always have to go to the database. Like always think of, stop thinking of data needs to be always like calculated right now, right? Think of that because it's having its own recency policies, things like that. The world of event-driven data, and if you're not familiar, check it out, like is the world that thinks about it. Well, let's go to a little bit newer stuff. WASM, right? If you're not familiar with WebAssembly, especially if you are working in non-web environment, WebAssembly can be a good opportunity for you to bring the code from older technologies. Not older, technologies that usually run in non-web environment, in non-browser environment over to the browser. And not only to the browser, Fastly in particular runs it on the edge, right? So basically similar idea of universal JavaScript, but not JavaScript, but any language running in different isolates, I think they're called, but basically isolated environments both for security. So basically WASM is not just compiling another language. It has a lot of features that are that made Fastly choose it for the edge, for example, right? Some of these things, like as I said, edge compute emerges, edge services. Like I think the term I heard was distributed by default and scalable, right? Things that are built with the opposite thought in mind from you control everything in one place, right? It might be marketing spiel, I don't know. But at least that's like a thing to look out for, right? Like if you see that, don't think of it as, oh, it's just another cloud compute, right? It's not another cloud service or, serverless thing. It's a little different. It's built differently on purpose. At least they tell us that they do. And I don't mean Fastly, I mean all of them. All of the companies doing that. I recently learned about Hono framework, which is a framework that lets you build your JavaScript specifically applications and run it and basically use adapters to run it on the edge or on Lambda or on server, right? Like, I mean, they're not necessarily as crazy as I am with this idea, right? Like of like universal access on Mars rover, but at least they are enabling this cloud computation to be more framework supported, I should say, right? And probably more will emerge in a similar fashion. I just recently learned about this one. You can tell me there may be others. Now, Vercel recently posted about 6 months ago a good article. By the way, Malte Ubel, their CTO, is former AMP engineer from Google who created AMP, right? Like he knows performance well, right? And he wrote this article about framework-defined infrastructure, right? It's a way to deploy application decision is made on a framework level, right? You as a developer, you don't do that. If you're familiar with Next.js app router specifically, right? Like I think they started rolling it out in 13.5. So if you use Next.js earlier version, definitely take a look at the app router as opposed to page routers that they used before. This thing is opening a door in my, I mean, they're definitely planning for it, right? Like they're publishing it already, right? It opens the door for the compiler or a framework defining the deployment architecture, which is very similar to the concept I'm talking about, maybe under today's infrastructure constraints, right? But, you know, that's understandable. Another thing that I learned recently is Cloudflare released this RPC, Remote Process Communication. Very old name. I don't know if any of you even remember it, but it was basically how do you make a call to another server without actually thinking about being another server? It's very similar, not similar. It's literally the same thing as I was just showing you, like for remote communication. Maybe not to define the topology, but to actually like you make a call, right, to a function, you get the result. What else do you need, right? And they made that specifically for their edge compute services and to enable some of that. So definitely check it out. And one other thing I want to mention, I kind of hinted at it a few times, but we want to make those architectural decisions not only based on cost or complexity or something, but based on performance. So do your instrumentation as well, right? Real user measurement is the way we do instrumentation in the browser today, right? As opposed to APM, which was application performance monitoring, I think, or management, which was effectively where like all server instrumentations come to it. You're probably more familiar with those than real user measurement, but those are just sides of the same puzzle. And yeah, industry is hard to change. You don't, like, not all of the APM companies became RAM companies, and you know, it's a hard problem. I don't want to say anything, but if we need to measure across your stack and across all of those application nodes, architecture nodes or whatever environments I called them. Sorry, I forgot my own name for it. But then we need to know how to do the measurement, how to do the open telemetry. Maybe is another thing that kind of emerged from the server and cloud compute world, and did not get to RAM world as well yet, right? But I think it's all the same space. When I said we want to use compilers to compile the topology into specific architecture, that is one approach. But we can do runtime as well, right? At runtime, we can make a decision where to execute certain type of code. If the user came to our website on a low-power device, we can make a different decision from a desktop, right? If they came from a different location, we can make a different decision. First view versus second view, like if you're familiar with service workers, those are two very different experiences. If the user never came to you, you still serve regular web application. The moment you install a service worker, that's next view will benefit from it. Like that's just a good example of it. But some of those decisions can be made at runtime. And who will make a runtime decision for us? AI. I just had to say it. It wouldn't be a presentation without the word AI in it, right? But I wouldn't be surprised if that's an application that actually will be used for that, because imagine how much signal we have. We removed all of that thinking from developers, right, on purpose, right? We told them, like, build the application logic, which means that some roles need to emerge that will be able to make that decisions, and those roles will be very hard, right? Like, we purposefully stopped making them application roles. They are operational roles, and they will be hard. A lot of signal, it's hard to make those decisions. So our friend with 2 letters can help us with that. So that's it. I mean, I told you I don't have many answers for you, probably questions, but please feel free to reach out to me. If you scan that, and you can enter your personal information. It will send you my information, so you'll be able to contact me, or just, check me out on social media. Thank you. So I know I asked all the questions, but maybe you do have some. Please feel free. Very obvious, right? No questions.
I have opinions.
Go ahead, Jacob. Go ahead.
Well, I mean, I think everything should be WASM, and that solves everything. That's my big opinion. And we need to see the component model before we worry about all these flexible architectures. But that's years away, to your earlier point, which is we're not really seeing the advantages of all previous models or single page web applications, and people haven't really taken it up. So I think that's like largely what I think is the future that will allow us to, say the hell with AWS and say the hell with these terrible old CMSs we're all using, and say the hell with Fastly and Cloudflare and Akamai and all of them, right? And I think that's the ideal future, but we're probably technically 3 to 5 years away from that being.
Yeah, and I personally feel that I went into this crazy thinking because some of those innovations, including service workers, including PWS, that a lot of money went into describing and explaining, are still very hard to go into. And I would imagine edge compute will have the same very problem. People will just have to rack their brain trying to architect their systems to fit the new paradigm. And yes, for some applications it will be very obvious, but the moment you build a bigger application, it would be a challenge to start thinking in many, many architectures, right? And that's kind of what I'm calling for.
Yeah. I mean, like, we run into problems. People want a database all the time. Or like, Cell gave up recently on trying to do Edge, right? So it's like, I mean, it's not just us. It's not like it's an everyone problem, right? People want a lot, and then it makes it really, really challenging. I don't know. I would also say I disagree with you on one thing.
Okay.
One assumption you made. Sometimes I think blowing it all up is the right thing to do. Just start fresh. Like, I think a lot of people have a lot of legacy code, and if you just start it all over.
I'm with you. By the way, public announcement, I'm unemployed if anyone wants to hire me. I can start fresh easily. Especially if you have code that you don't like, I can come in and say, throw it away.
I actually wanted to slightly disagree. I think that there are times where the application runs, it completely doesn't matter, and the WASM could be a good answer to that, especially for heavier computations. There's also heavier transport at the same time. You have to transport a lot more code. So, for example, if you need to transport HLS, for example, if you want to rely on WASM rather than on JavaScript like we used to with years ago. But at the same time, there are applications where the business logic has to be so precise, and the company who owns that business logic is responsible for what it offers to the client, that you cannot afford to run that on the client side, where even potentially a bad actor can try to pretend to be that application that runs on your client side and pass the data back to the server, just even for storage purposes, in the form that's going to create certain bad mutations for the data.
Yeah.
Right? So you have to. There are applications for this, and there are applications for that. A couple of examples where I can think of right away where this usage would be is, for example, if you have a relatively small application with an email client, and somebody wants to search, right? So at first you would search back on the server side, but slowly as the client is interacting with the application, you can start fetching that data, or at least some amount, so at some point we switch to searching on the client side. Instead of writing that application twice, you can rely on this kind of application where you can shift tilt to, like, I have enough to be able to do at least a preliminary search, give you an immediate response. If you're not satisfied, they give you first 50, you want to see more, let's go back to the server, right? Similarly, this could be a offline, or you can imagine the power device, bad network. You can make these decisions where I'll do the same operation. I might get better results if I do it elsewhere, but I have a trade-off.
Yep.
Right?
Yep.
So the trade-off could be that's a trigger that allows you to decide which environment do I want to run this on. Because sometimes that trade-off would be more worth to give that, but sometimes not.
Yep. And this is exactly my point, where like we don't have one answer. We don't have one answer, like always run on the server. The answer is, well, some payloads can only run in some environments. I mean, it's obvious if you want to change the DOM on the client browser. Perfect. So exactly, and security consideration is another constraint that we'll be describing. I kind of went very easy on the demo, right? I just wrote the code in topology, but there are other things like constraints, like speed requirements that you want for individual calls, right? Security environments. I can only think of 500 of them, right? Like right away, and you probably know more even, right? So we can compile the topology or application architecture based on the requirements rather than the one decision we made early, right? Maybe two. So, yeah.
So, I have a strangely large amount of experience with refactoring. This is what I did for many years. Taking old code, making it new. So, re-architecting as an idea is nice, but what I'm wondering is, in your case, wouldn't we achieve similar results via containerization? If you just split apps into smaller pieces and start re-architecting the compose, the Docker compose?
I want to say I'm not familiar with containerization to the level where my answer will be particularly useful. But I feel like the way it is done today is primarily between data center to the cloud kind of migration level, right? So granularity might not be where we want it if you want to run a function in the main thread in the browser. You know what I mean? One function, right? However, I agree that maybe some of it will work, but I feel like even edge compute is already much more constrained environment than your cloud function. But even cloud functions, I don't think cannot run containers already, right? So it's like containerization to solve some of these problems is definitely the answer, right? Like we've seen that, like basically for scalability, for a few other reasons, even abstracting away environments, but like definitely together with maybe good API and interface layering as well. Like you wouldn't do containerization without ability to call another container and another environment, right? So like containers are just solving one type of the problem in here. And by the way, solving it properly. I mean, nothing wrong necessarily, but yeah.
Just to add on to everything that you just said, we used to have this issue when we used to pull in large amounts of data from the server. It would take way too long. We're talking about 6,000-7,000 entries coming in at the same time for drop down. It was silly. So one of the ways that it's also a decision matrix that we have to sometimes figure out.
Yep.
About say you have 7,000 entries for drop list that you wish to keep. You can choose to keep it on an API and call it every time this customer calls it, or you can cache it on your CMS and keep it that way. But what happens very often is that when you make a decision around your architecture, is that they've already decided that those 7,000 lists will come from an API. Making the call, putting it on the CMS, taking the effort of putting it on the CMS is a very long pipeline.
I think you answered your own question, basically, right? Like decision was already made and constrains you more than it should, right? Basically, you couldn't predict or you did not put enough effort into predicting, whatever the reason is, doesn't matter, right? Like the fact that there is work to be done if you want to accomplish if you want to reap the benefit that you want to reap. In our conversation is probably performance, right? You don't know, right? But can you make a choice in this diagram, right? Can you make that choice for each type of operation? On this scale, it's so much easier. That's why I kind of included this in this presentation, right? So I think you can make that choice. And yes, this is a $1 trillion investment or whatever the cost of our space program is, right? Today and for the next 20, 30 years, right? I didn't say it was cheap. I didn't say it was worth it, the money, right? Like, you need to figure it out, right? And maybe some of this can still be beneficial, but some of it will not be, right? In fact, I'm not even saying that you should make the right choice right away and just split everything and like move everything in the right places. No, you probably don't have money, you don't have expertise, you don't have time to do that. If you start building it that way, you will basically make those decisions as you go. You will realize, oh, now I can afford CDN, I will use it. You know, just be open-minded. Don't think, oh, we cannot use it because our architecture is wrong. Well, make it flexible, right? Make the choice that your logo doesn't change every year. Your title of the name of the company doesn't change. Maybe the copy of the product on your product page changes only when your editor changes it and not when every user comes, right? Make those choices. Draw your diagrams, workflows and stuff like that. Make that decision like you would in this case, right? And again, I don't know if it's easy to make. I don't know if anyone made the decision on this scale, but yeah.
I wanted to jump in on that. I think that containerization itself is a little bit of a diversion from the topic, but the other term that you use, the composition, is very important because you can take a monolith, right, and have your application. You can say that I'm not going to focus on the whole thing. I'm just going to focus on one application. I'm going to decompose that. And I'll figure out how to make sure that the traffic, in simple terms, right, the traffic goes to the decomposed microservice, all the modern terms, right, instead of to the monolith. And as long as nothing else depends on that, you're done. Like you succeeded, and this is where you can say, it's like, oh, even this architecture might work specifically for that application, even though the rest of it is going to be stuck for the next 20 years, and it's going to be really hard for us to do it. But with this mindset, it allows you to cheapen it with little bit by little bit by little bit, and eventually it creates enough of that weight where everybody else starts thinking the same way.
And by the way, I didn't mean to create a topic of how do you pull off re-architecture at the large corporations, for example, which is hard topic, you know.
I just want to jump in on the containerization.
There you go.
If you forget about Docker and you just think about virtualized environments of where my code is running, that's what you're describing. It already has the model for what resources do I need, what are my performance characteristics, where do I deploy it. Just forget about Docker.
Yeah. Maybe it's WASM isolates, right? Maybe that's our new container story, right? I saw a hand over there.
Yes, a quick question. Can you share a few KPIs that indicates that app or the service requires the optimization? Let's say there's an app that works fine, no feedbacks, no complaints. Like, how do we find out that there's optimization is needed?
Yeah, this is a question I often hear in performance conversations, right? Like, no user told us that it's slow, right? Yeah, those users didn't use your application; they left. So you don't talk to them, right? So yeah, that's why my second to last point was that real user measurement and ability to measure. And even with real user measurement today, it's a challenge, right? Like, did you measure every user who bounced from your ad? No, you didn't, right? So this is the conversation I have a lot with the businesses when they like, okay, prove that we need you. Prove that you need we need to care about performance. I'm like, well, how much of your business you don't care about, right? Well, the one that you don't have today, you already don't care about, right? Like, but do you want more business? You can do it, right? Again, this is simplification. We have a lot of talks on the topic. I don't want to make it into a simple one. KPIs wise, in capitalism world, it's dollars. In non-capitalism world, it's purpose of what is this application for, right? In the end, that's the most universal KPI.
We've been using a lot of A/B testing for this, and the KPIs are specific to your goals, right?
Yeah. I come from e-commerce most recently. In there, why do we all love working for e-commerce business? They have a very simple one. The person either checked out and you have $1, or if they didn't, right? In the end of the transaction, which is good for them. Sometimes it's bad for them because they are blind to everything else. But again, media business, every company has a KPI, right? And not one, right? They oftentimes conflict with each other. Like, again, dollars conflict with long-term retention, like short-term business conflicts with long-term business, you know, like there's no simple answer for that. But we could probably think of for any business. Yeah, go ahead.
Okay. Who asked that question?
Yeah.
Who said it? Oh.
Paul did.
I know, so we use this at our company for SIPs. Google, all their web vitals, they have like a NPM package that'll measure it for you, and then they have like a way where you can send it to Google Analytics, but I bet you can type it into something else. So then you can do stuff like connect last contentful paint or some other like web vitals that are important, and then connect it to like Bounce, which is important for us, could be for other websites too. And then what you hopefully will see is like people with better performance metrics are less likely to bounce, or people with whatever are more likely to stay engaged because they stay on the page longer. So that's kind of how we look at it.
What was the name?
I would just like it's Google's Web Vitals, but they have like a specific like NPM package where they hook into this like performance library into the browser natively, and then kind of do all the heavy lifting for you. And then if you use Google Analytics, you can kind of type it in there. If you don't, then you still get the number, so you can probably type it into whatever analytics system you're using.
Yeah, and when obviously we are at a performance meetup, like this conversation happens a lot about performance, how performance aspects of your application affect KPIs, right? But maybe it's not the only performance question. This might be solving other problems you have because you couldn't re-architect, right? You probably have some other thoughts if you, in your experience where that stopped you from not being able to re-architect. I mean, I'm definitely thinking performance latency. This not to scale quote, by the way, is on purpose. Imagine drawing your architectural diagrams not based on how much attention you pay to a node of the diagram and to the line of the diagram, but how much time is spent in it. Imagine how different your architecture diagrams would look like, and bring back, maybe you should pay attention to different pieces to it, right? So, yeah, anyhow, not to scale. Who recognized the quote? No? Anyone? Not to scale, and I didn't have time to paint it? No? Back to the Future? No? No, nobody? Okay. Sorry. I'm just a geek. Max.
So, how much of this idea is the concept of writing your application in a single language that can run anywhere versus just structuring it in such a way that it can, let's say, dynamically retarget where it talks to?
Yeah, I don't think it's writing it in single language universally, no. But I think a lot of the environments you want to run in today run JavaScript, right? That's kind of why I chose the first implementation in JavaScript. WebAssembly is the other answer to it. That's why I brought it up. But you wouldn't run JavaScript everywhere, right? So I don't, in fact, the browser has other languages in it. Right? Like, what's the best language to display something on a screen? HTML and CSS, not JavaScript, right? In fact, they convert to pixels much more directly. In fact, JavaScript doesn't usually, it usually generates HTML and CSS, right? Or HTML usually, right? So, or DOM for that matter, which is a whole other story, right? So, I would say the short-term story for a lot of it is probably JavaScript. While we kind of pilot this migration between layers, and maybe it's not JavaScript, maybe for web it probably is JavaScript, but for other environments maybe it's different language, right? It's just, I just cannot wrap my brain around that very well, I can imagine maybe in IoT devices have very different portability question, right? Right, without containerization you can still have portability, and JavaScript is just one answer to that.
Yeah, I saw the same. I mean, I admire sort of the idea that you want to stay flexible and run your code where it's meant to go. To kind of build a framework seems hard, because even with JavaScript, you have different runtimes, Node, client, Fastly, Blossom, right?
Yeah.
And they all have different capabilities. And even we use Fastly a lot at First Dibs, where I work. And even their SDK for their API doesn't run in their compute environment because it's probably meant for a node environment, right? So even in those cases, that compiler that you had in there is going to have to be super smart.
I don't think the answer is there today. I think the question is there, and I think all of us are solving this problem today, just usually on one little use case, right? Like, you know, well, the fact that browsers now and server now support ES6 together, right? Like, that was solved to some degree. Yes, some APIs are not available. You cannot read the file on the browser, right? Without permissions, I think. Maybe with permissions you can, but you know. So I think a lot of these conversations we are solving today, and that's kind of why I brought it up. Because if it was just crazy idea that nobody like thought about, maybe I would keep quiet. But I think we are closer to it than we think. Maybe another 50 years and we get there.
I hear people that tell me that the next programming language is English anyhow because AI would do it for us, of course.
Yeah. Who knows?
Still, I
Maybe.
think that TypeScript, for example, right? You have that compiles into JavaScript. It doesn't have to. It could be anything that you wanted it to run on, as long as the compiler is powerful enough. For this analogy here, I wonder. I mean, what we didn't talk about too much is really business use case. Why do we do it in the first place? And for this example here, the whole dilemma is that you send up this little rover and you can never ever touch it again.
Until you fly there yourself.
You fly there, which is then defeating the purpose of the rover. You won't need it anymore if you fly there. Then it's pretty much just garbage and it goes into a museum because you're there.
Frankly, I actually don't know enough about exploration plans, but from what I understand, the newer computers and all of that can be reprogrammed, and they're being reprogrammed remotely, right? So it might not be as crazy of an idea, but
at least when it comes to the hardware of what it is capable of, you set it off and it's gone.
Yeah.
Is that the case for a web application in general?
Yes.
yeah, please.
I think the moment you send an application to the client's browser, your hope is that the client is going to be happy with what the client got. At that point, it's too late to rethink what the client gets. Is the client going to be able to succeed with the operation they're trying to do, etc. And this is why your thinking has to be before you ship that code off there, right? The client is that marks, right? We happen to be on the other end for some reason. But the moment it gets there, it's too late to try to change anything. Unless you have put some kind of instrumentation in place that can catch that error and says, oh, can't you do the client?
Yeah. How many times did you tell service worker to just reply to all the requests, and all the users they got it? Well, eventually they will get rid of it. Maybe not, or edge caches, or basically, you know, what's the hardest problems in computer science, right? There are two: naming things, cache invalidation, and off by one errors, right? So cache invalidation is one huge problem, like, which is kind of what we're talking about. Can we replace the rover? We could replace it if it wasn't for the cost. Same with the mobile communication. Imagine a situation where you had 28 baud modem communicating between Moscow and Antarctica, right? You would make your choices very differently, and I picked specific modem speed because I remember that moment. You know, my father was on expedition in Antarctica, and we communicated with him. Like, you had little time, you had limited bandwidth, more limited than we got used to today, right? And look, those choices are same choices. We got used to abundance of computer power, network power, but some of those are not abundant, like latency. Latency is not abundant, right? Like, much harder to accomplish. Okay, these days a little easier than we had before, but so. Okay, I don't know where you went with that, but I feel like you have this is I purposefully zoomed out to make some of these answers more obvious than in the on Earth use case.
Is what you said about the base. That you send off your rover, and there's a base, but there is no base yet.
Yep.
So how do you architect around something that you don't know how it's going to look like? So this is very different from what you normally would think of architecture, like building something out that is going to stay. I think none of that is going to stay longer than the business case behind it, like looking for a nice plant, like you said. Yeah. And if you're there, then you don't need that robot no more, then you can start from scratch. Until then, you need to have it as modular as you can so that you can change tiny parts of it. A good old agile, right?
Yeah.
You build and refactor.
Yeah.
And you keep going.
And yeah, before we did modularity, before we did API strategy, we just rewrote things, right? Refactor, rewrote, built from scratch. Some of these techniques allow easier thing, right? Unfortunately, API, like as we did it, like RESTful API, kind of it simplified our life because it was simple. But like if you ever tried edge caching your API, you would know that there is no like universal abstraction, right? You always need to think. You need to solve these problems as you go. And yeah, I don't know how you, as I said, like the what was it like before you have the framework or code or whatever. What should I do today? Yeah, break it down, make independent layers, things like that. Who am I to tell you like how to do enterprise engineering? I actually have no clue, but the web, I have a little bit more clue. But I think like these are not my wise words. It's just common sense, right? Anyone else? No? Jen, do you still have that comment or question?
Oh, I was going to build off of what Jacob was saying about blowing things up entirely. So I think product for Dutch.com out of that slate, and it was just like 7 years old. The React app, it's been getting slow. So we actually are rebuilding Glitch from scratch in the public. So you could preview.glitch.com and see like faster, more accessible, but still kind of like broken as we're building it out in the open. And we're hoping that that can kind of model other places going, like you can build a second version out in the open with community, especially if your platform is like community driven. And we're finding that it's built like on old React. Now we're rebuilding it in Remix.js, which is now being folded into the Remix router. But performance is just so much better, like out of the box today, and we found it like as we rip it up and start again, what is new then?
Yeah. Sometimes your dream comes true, right? But I'm not saying that you shouldn't dream like that, right? I'm saying that sometimes the cost is too high. Like we cannot afford not doing something like that, especially as our applications become bigger and more complex, right? The fact that many of us want the freaking offline access for our web applications, but how big of a pool that is for us to think about it,
And you do have, like, we did have to sacrifice like innovation and new features so that we can do this work, and then like our velocity once we like hunt over. We'll be able to build.
Yeah. That's usually the hope, right? Oftentimes it works. Not always, but yeah. Thank you. Yeah. Again, as I said, we have 50 years before we need this badly, and maybe 100. I don't know. So crazy idea. Thank you. Let's do the networking portion and discuss the rest afterwards. Thank you very much. Thank you for indulging me.